The limit from the left is 1/6. The limit from the right is 1/6. And it will still have an open point, but once we put in 3, 1/6, it will fill it in. But only at 3, of course. The other one stays as a vertical asymptote. Very good pick. I wanted to illustrate something like this, 47. Any questions? Sorry, I didn't mean to, I'm sorry, let me go back. I forgot to ask. Always stop me. Any questions? So this is how we make it continuous. It's guaranteed that it's continuous now at 3. Because the function at 3 exists as x1 over x plus 3 at 3. I wrote it not equal to 3 because the original function, but maybe we can skip this because this is not for this function. So we don't really have to write that x not equal 3. X not equal -3, I meant. This is, that has to be. Okay, that was from the original function. But this function becomes now continuous at 3 as long as we plug in 3 and we get 1/6. Now the limit from the left is 1/6 and the limit from the right is 1/6. Okay, so that's my page 11 now. So I wanted to work on this problem because it only illustrates again. So this is 47. And we have f of x equals cx squared plus 2x for x less than 2, and x cubed minus cx for x greater than or equal to 2. They're asking us to find c to make f continuous everywhere, for f of x continuous on everywhere, meaning this, all your numbers. So what I have to do first, I have to state one thing. This and this are what type of functions? What type of functions are they?
Are they cubic functions?
Polynomial in general. Second degree, third degree. Very good. Well, there are polynomial functions that are always continuous. So this is the first statement. Polynomial functions are always continuous. So these pieces are always continuous. But what could be the problem? It may not be continuous at 2. Continuity at x equals 2. So this is continuity at the point. What is the definition of continuity at the point?
Limit of f of
Yes.
Limit of f of x.
Right. From the left of 2. Which branch?
Oh, c.
Yes.
C.
Exactly.
Yes.
Awesome. Must equal the limit as x approaches 2 from the right. It's a silly question, which branch, because there is only one left. And this must equal, otherwise it's not continuous at that point.
The limit of as x approaches x from both, as x approaches 2 from both sides of f of x.
We already stated that. The
value of the function.
Yes, f of 2. So one more time. I know this is new, so let's go back. The limit from the left equals the limit from the right equals the function value at that point, which is still the same thing with f of 3 because I wrote here 3. Perfect. Good. So can anyone give us this limit? Can anyone give us this limit and then f of 2? But of course, question mark, right? We have to make it be continuous. So can anyone give us this limit? Can anyone give us this limit?
The first one's going to be 4c plus 4.
Excellent. Great job.
And that'll be 8 minus 2c.
Excellent. And f of 2, I don't know. Which branch will I plug into? Top or bottom?
The bottom.
Yes, of course. Thank you. Very good. So it's still the same thing, still 8 minus 2c. So this is all I need. This is redundant because it's here. So I move 2c to this side. I move 4 to the side. Remember, when I move a term from one side to the other, I change its sign. I had a 4c and I'm bringing a 2c. This was 4 with positive. It has to go back negative to the other side. 8 minus 4 is 4. So how much is c?
2/3.
Yes, awesome, 2/3. I have to go back and put it in. So I have to say f of x equals 2/3 x squared plus 2x for x less than 2, and x cubed minus 2/3 x for x greater than 2, guaranteed, W here, to be what? On negative infinity to infinity.
Continuous?
Yes, it's guaranteed. How come? It's continuous because these are two polynomial functions and always continuous. And continuity at x equals 2 gave us c to be 2/3. We put 2/3 in place of c. This function now is guaranteed to be continuous on the left of 2, continuous on the right of 2, and continuous at 2. Guaranteed. Only with 2/3. If you replace c by anything else, it's not going to be continuous. Guaranteed is not going to be continuous for anything else. Any questions? That's about continuity. One theorem here, IVT, intermediate value theorem for continuous functions. I'm going to present the simplest option or variant, if you want, of this theorem. So let's say I have a continuous function. Continuous on the interval a comma b. Here's my interval a comma b. Would you agree? From my graph, is the function continuous on the interval a comma b?
Yes.
Also from my graph, would you agree that f of a is a negative number and f of b is a positive number?
Yes.
Perfect. From these three conclusions, by IVT, there exists a number c. See? I meant this belongs to. I jumped over c. Sorry. There must exist a number c And this is the belong that you asked me a long time ago. I was getting ready for this. So this is the belongs in the interval. So by IVT, there exists, I will find a number C in the open interval A comma B such that f of C must be
somewhere between.
exactly,
Okay.
there is no between. Exactly what?
C.
How much? It's on the x-axis. What can it be?
0.
Exactly. So what does this say? If I solve an equation f of x equals 0, and this function is continuous, and it changes sign on the given interval. So if I'm asked to solve this equation on a comma b, and the function is continuous, and it changes sign from negative to positive, or from positive to negative, I don't care. But it changes sign on the given interval. It must have a 0, or an x-intercept, or the equation must have a solution in the interval a comma b. Guaranteed. If it is continuous. If it's not continuous, I cannot use the IVT. I can use the IVT only if I show that the function is continuous, the function changes sign on the given interval, and the given interval has to be 1 unit interval. Meaning, not from 10 to 20. This is not a 1 unit interval. 1 unit or smaller. This is a 1 unit interval. This is a 1 unit interval. So it has to be a 1 unit interval or smaller, but 1 unit is good enough. So function continuous and changes sign on that interval, then I have to it's guaranteed by the IVT that there is a 0, at least 1. It could be more, but at least 1 0 between A and B, either 0 or x-intercept of the function or a solution to the equation. Guaranteed. What is the problem with IVT? A big one. IVT does not find C. No, it does not. But it guarantees that there is a C between these two. There is a 0 of the function or a solution between these two, or between these two, or between these two. It guarantees it. It must be there. If the function is continuous and changes sign, either from positive to negative or negative to positive, there must be a C. Now you have to wait till chapter 4. In chapter 4, using Newton's method, we will find C. But IVT only tells us where to look for it. It does not determine it. So let's apply IVT. Here it is. Let's choose an IVT question.
57.
57. I'm on page 13. 57. One time I was coming out of class and I did not have these pages numbered. And you don't want to know what happened. I just had to spend a couple of minutes putting them in the correct order. Not a big deal, but still. So here's an equation which doesn't, it's not useful. I can change it the way I like. Not really, as long as it's legitimate. Solving this equation is like solving this equation because I moved the terms to one side. I needed that because I need this function. And I need to say that this piece and this piece and this piece are all continuous. It's a continuous function on at least 0, 1, as you see, a 1 unit interval. as a sum or difference of three continuous functions. And this is another theorem. If I have any number of continuous functions, if I add them and subtract them, I always get a continuous function. So this first piece is done. Now I have to find f of 0 and I have to find f of 1. So I put it in the graphing calculator. I have it in y equals, so I clear whatever I have here. And I have e to the x. And then I have minus 3 plus 2x. And then I plug in, oops, I didn't mean that. I only meant this. I want to plug in 0 and 1. And they better have opposite signs. If they don't, IVT is not applicable and there is no solution there. But f of 0, you don't have to copy the number. You just have to write less than 0. And f of 1 is greater than 0. From 1 and 2, by IVT, there exists a C in the open interval 0, 1, such that f of C must be
0.
That's it. It must be 0. Because the function is continuous and it changes sign. If both are positive, the theorem is not applicable. If both are negative, the theorem is not applicable. We cannot conclude that. Any questions? Any questions? Okay, perfect. That's all about IVT. That's all. Show that the function is continuous on the given interval. If it's not, we cannot continue. If it's not continuous on the given interval, you're done. IVT is not applicable.